In this video tutorial, we're going to be looking at secants and tangents that intersect inside of a circle. So you can see in this example here, we have a secant line AC and secant line BD. They are secants because they each intersect the circle twice, but they intersect here in the middle of the circle. So they're inside of the circle. This means that we can find the measure of these angles, angles 1 and 2, using a specific formula. So if we wanted to find the measure of angle 1, we find this by, and it tells you over here, that it's going to equal half the sum of the measures of the intercepted arcs. So for this particular angle, it intercepts this arc over here, and then we can see that there's an intercepted arc over here. So if I take these two arcs, add them together, and divide by 2, we're going to get the measure of angle 1. So angle 1 is equal to half of the sum of the measure of arc AD and the measure of arc BC. You could also write it as the measure of arc AD plus the measure of arc BC divided by 2. And oftentimes I utilize it in this format because it's easy when we start to set up a proportion and solve for missing pieces. So then the measure of angle 2, this angle up here, that angle intercepts this arc AB, and then this arc DC is intercepted as well. So we have that the measure of angle 2 is half of the sum of those arc measures. So the measure of arc AB plus the measure of arc DC. And again, you could also say it as the measure of arc AB plus the measure of arc DC divided by 2. So let's look at an example. In number 1, we want to calculate the measure of angle AED. So angle AED is this angle here. So the measure is going to be equivalent to half of the sum of the intercepted arcs. So we have arc here, AD, and arc BC, whose measures are 45 degrees and 109 degrees. So the measure of angle AED is equal to half of that sum. So 45 plus 109 divided by 2, and in that case, you would get 77 degrees. In number 2, the measure of angle STR is this angle here. So I can see the corresponding arcs that are intercepted. So the measure of angle STR is equivalent to the sum of those two arcs divided by 2. So 112 plus 186 divided by 2. 112 plus 186 is 298. Divided by 2 is 149 degrees. In number 3, we're looking for the measure of angle YWX, which is this angle here. Now notice that the angle that I'm looking for, the intercepted arcs are not given. So I have these arcs. I have the arc measure 43 degrees and 81 degrees. But what this is going to do is it's going to be able to use the 43 and the 81 to actually find this angle here, XWZ, which is vertical to this angle over here. So either of these, YWV or XWZ, could be found finding or using these arc measures. But that's still helpful to us. So I'm first going to find the measure of one of those angles. So for instance, YWV. YWV is equal to the 43 plus the 81 divided by 2. 43 plus 81 divided by 2 is 62 degrees. So this angle here is 62 degrees, and this angle is also 62 degrees. And think about why that's helpful. I notice that angle YWX and angle XWZ are a linear pair. They form a 180-degree straight angle. So if I actually want to find the measure of angle YWX, we can take 180 degrees and subtract 62 degrees to get that angle. And what we would be left with is an angle of 50, We take away, it would be 118 degrees. Sometimes you might be asked to find the measure of an arc versus the angle. So in this case, I'm looking for the measure of arc LK. That's this arc here, which I can see is intercepted by this angle LNK. I also have this arc over here. So remember, our formula is equal to, or the angle is equal to half the arc's sum. So again, we can say the angle, but in this case, the angle is given. So the angle, 62 degrees, is equal to half of the sum of these two arcs. Well, one of them is 74, and the other one we're looking for. So maybe I'll call that x. So 74 plus x divided by 2 should equal 62. We can solve this like a proportion, right? 62 is over 1. So 1 times the quantity 74 plus x is 74 plus x. And that should equal the other cross product, 62 times 2, which would be 144. So if we want to solve that, then all we have to do is take away 74 from 144, and we get that x equals 50 degrees. So the measure of arc LK is 50 degrees. Number 5, we're looking for the measure of arc CDE. So let's always highlight what it is that we're looking for. So arc CDE is that major arc there. I can see that angle CHE is 128 degrees, and then the arc over here is 73. So our equation would say that 128 should equal those two arc measures added together and divided by 2. So I can call that arc X. So it would be 73 plus X divided by 2. Solve it like a proportion. So 128 times 2 is 256 for that cross product. It should equal the other cross product, which is 73 plus x times 1. So then to solve for x, we would take 73 away from both sides, and we would get that x is equivalent to 183. Last one, the measure of arc QT. So here is arc QT. I can also see that we have arc RS, which has a measure of 95 degrees. But those two arcs would actually help me to find this angle here, which is QUT, or this angle here, which is vertical to that same measure, RUS. So this 79 degrees is not going to be part of that same equation. So if I'm solving for arc QT here, I really need this angle. But I can find that angle because angle RUQ and QUT are a linear pair. I can see that they make a straight angle. So this angle right here is 180 minus 79, which is 101 degrees. So if we know that the measure of angle QUT is 101 degrees, that's the angle that we'll use in our formula. So 101 will equal the sum of those two arc measures, 95 plus x, divided by 2. Again, we solve using cross products. 101 times 2 is 202. That equals our other cross product, which is 95 plus x. Take 95 away from both sides, so 202 minus 95 is 107, which means the measure of arc QT is 107 degrees.